So hello and a warm welcome to the fifth video in this little series where I describe the J joint 5 assembly. This assembly is also quite different from the base assembly. Not also in the structural component design part, but also in the design part where I routed the belt differently. So the J5 is a very clever idea, and I really have to compliment Chris Arnin here, because the motor 5 has a not a gear reduction, but is reduced via the via this screw, and this screw drives a drive screw, which I didn't design yet. Maybe I should redesign it. Whatever. And this drive screw drives a mechanism that attaches to a belt, and this belt moves the joint 6 in this axis. So it's quite clever, because the motor is back here and it rotates the motor on this end, which also of course means that the moment arm of the heavy motor is way nearer to the joint 2, and this means that there's less strain on in the whole assembly. But now to the base design. In the base design, the joint 5 housing was split into many different parts, and I mostly combined them all and upgraded some parts, because in the base design, if we were to hide everything else and just show the J5 main body, which is an assembly from the base design of very different and many parts. Because in the base design you had one aluminum part, which is where basically the enclosure for the drive mechanism for the screw, and housing for the mechanism that drove the belt. We had one different part that basically was here, that held the taper roller bearing and screwed into the J5 main housing. And we had 3D printed parts that enclosed the whole assembly to encapsulate the belt, so you didn't pinch your little fingers when the motor was running, when the robot was running. And also, as far as I could tell, the main strain from the belt tension got transferred via the J6 assembly, which is fine if you make it out of aluminium, but it's very not fine when you make it out of weak plastic. So if I were to highlight the J6, in the base design, basically you would have belt tension that would apply a force on the J6 or J5 in this case pulley, that would put strain on the J6 housing, because the housing was only held in place via taper roller bearing that seats in here. This taper roller bearing, and the counterpart would be some axial roller bearing and a tensioning mechanism. So all the force would be transferred via the J6 housing, and I didn't want that. I wanted to support the J6 J6 assembly on the other side as well. That's why I designed a little stud here, an 8mm stud that seats a 608 skater roller bearing, and those are readily available. And I implemented another 608 bearing on the belt tensioning mechanism that I redesigned. I redesigned the belt tensioning mechanism because this is also the case where I bought a different size belt, I think. Yeah, I'm pretty sure. And that's why I had to accommodate a different tensioning mechanism. And I also wanted a different tensioning mechanism because on the base design, on the calibration side, you would physically move this into 105 degree, so to 85, then tension down the pulley, and the carriage would hit the limit switch, which is seated on this little rectangular cutout, and you would mechanically calibrate the robot via this application. Well, now I redesigned the J6, so I couldn't do that, but we'll come to that later. So also this roller bearing that implements allows me to tension the belt quite nicely, because as well I just have to adjust the radius on this circle to accommodate for different tensions on the belt, because of course the belt gets routed through the J5 pulley around the axial radial bearing here, and rides on top of this radius of this round circle. Yeah, the main housing is attached to the robot via the metal J4 main shaft, and I didn't glue it in place yet because I want to maybe disassemble the whole robot again, but I put some J4 heatset inserts here on the bottom and on the other side, of course, so it is still held very securely in place. Also, the diameter is of course 25mm on the J5 housing, so it is still a tight fit, and I had to use quite a bit of force to get the housing on the shaft, so I'm not worried that it might come loose in the next future. Oh yeah, and of course the J5 motor is attached also to the J4 main shaft via this modified J5 motor mount. I modified just one dimension of it to accommodate the bigger bearings that I had to implement because I used metric bearings instead of imperial. That's the only difference there. So the motor gets screwed in place via 4 M3 screws, machine screws, and is held securely that way. And the machine screws have in the J5 motor mount have a cutout for the machine screw head here. So thanks for watching. not to the J6.